Hello, everyone. So, today the topic is event loop, which is a very, very common, very popular JavaScript concept. Event loop. So, without wasting time, let me quickly start. What is event loop? So, event loop in JavaScript, it exists there to handle asynchronous operations, to ensure that single-threaded JavaScript is a non-blocking behavior. So what does it mean? It simply means that with the single-threaded JavaScript, how we can achieve asynchronous operation in a non-blocking way, and this is where event loop concept comes in picture. There are very important components which are connected to event loop. I would like to describe those as well. So the very first is call stack. So call stacks is a place where function calls are placed and executed sequentially. Remember, call stack, it is a stack, right? So it is there to take and to execute functions in a sequence way. All right. Moving to the next, which is a web API. These are external components like timers, HTTP request. They handle asynchronous task. They are the one who handles asynchronous task, whichever is coming in. All right. Now, we have task queue. So task queue is something which is also sometimes called as callback queue. So this task queue, it stores task waiting to execute when the task is empty, when the stack is empty, meaning when the call stack is empty. So so task queue or callback queue, it has all the list of tasks that has to be executed. Executed where? In the call stack. Okay, so when the call stack is empty, these task queues will be these tasks from the task queue will be given to the call stack, and the call stack will execute it. Similarly, we have one more queue which is called microtask queue. So microtask queue is there for a special purpose. This handles higher priority queues. For example, promises. This is a higher priority queue or a task. So all these higher priority callbacks, they are stored in microtask queue, and they have always been given higher priority than a normal task queue. Okay, and what is event loop then? What role it is playing? So event loop is actually constantly checking the call stack. If the stack is empty, it will check, hey call stack, are you empty? Yes, I am empty is an answer from call stack. Then event loop moves the task from the task queue or micro task queue, which is a high priority queue, to the call stack for execution. That is pretty much all, the very basic understanding of event loop. I should give you one more real life analogy so that you can understand in a better way. All right. So imagine you are at a restaurant. Chef, okay, let's give a position chef to a call stack, prepares one dish or task at a time. So chef, who is a call stack, it prepares one dish or a task at a time. Waiters could be the web APIs. They take customer orders, for example, set timeout API calls to the kitchen and wait for the responses. So waiters could be the web APIs. They always take customer orders to the kitchen and they wait for the responses. Order queue, which is a normal task queue. Okay, it's where orders are waiting to be prepared by the chef. Similarly, we have priority orders. Okay, I think this is a very common example. Let's say there's a VIP guest is coming in. So all those VIP orders, for example, microtask, promises, queue microtask, they all go into the priority order queue. Okay, these are urgent tasks like VIP orders. They have to be served before the regular ones, which are stored in task queue. So again, repeating, call stack, a chef prepares one disk at a time. Waiters take customer orders and uh, set timeout and API calls, these could be correlated to the kitchen and wait for the responses. Order queue or normal traditional task queue is orders waiting for to be picked by the chef. Priority orders, they are urgent tasks or VIP orders. They have to be served before any order was picked from order queue. All right, the normal queue. So the chef works on one dish at a time. After finishing the current dish, they check the VIP orders, micro task queue first, and then they go to regular orders, which is the task queue or order queue. So I think this is pretty much all when it comes to explaining the the basic understanding of this event loop concept. Now let me give you more clarity about these with some real time code walkthroughs. So I have prepared compiles sort of 10 questions here, which will give you a more idea about event loop. So the question number one, which is here. So we see here console.log start and console.log end. So what is the output you're expecting here? So set timeout is a method which should go into the queue, and then you remember there are two queues, so normal queue and the priority queue. So priority queue is microtask queue, but this set timeout will go to the normal queue because promises and queue microtask, they are for the priority queue. So if I run this start and end will be printed first and then timeout executed, because this will go into the event queue and then task queue, and then event loop will pull in and then put it into call stack, and then call stack will run it synchronously. So start and end, they will be printed synchronously at the immediately, and then this will come later. So if I just run this question one, so it is start and timeout executed. Let me go and discuss about question number two. Over here we have set timeout and promise both. Set timeout, it go to the normal queue. Promise, it go to the priority queue. So when we have these two, so over here you can understand that start and end, they are in a synchronous way executed. So start and end will be printed first, and then out of this and this, the priority queue VIP orders will be taken first. So promise resolve will be printed next, and then timeout executed. So if I run this, so it will be start and promise resolved and timeout executed. Question number three. Over here, we have everything same, but we have two set timeouts. So timeout 1, timeout 2. So again, it's the same concept. This promise resolve will be printed after start and end. So start, end, and promise resolved. Because why this? Because this is in a VIP order. Okay, this is in a VIP order queue, which is a microtask queue. And then the normal order queue, because this timeout 1 will be pushed into the queue first, and then timeout 2. So timeout 1 will be popped pulled out first, and timeout 2 will be pulled out second. So start, end, promise resolved, timeout 1, timeout 2. So let me run this. Here we go. Start, end, promise resolved, promise timeout 1, timeout 2. Question number 4. Okay, over here we are talking about let. So this is a very important concept again. So set interval. Okay, so set interval, you see in this there is a check which is count equal to 3, then we are clearing the interval. But before that, you see 1000 milliseconds, meaning every 1 second this log interval executed will be printed, and count 1 will be increased, and the moment it reaches 3, it will clear the interval. So let me quickly run this, and it's very simple question, but most of the time confusing here. So interval executed 1 second, 2 second, and 3 second, 3 times it is printed. Okay. um okay, next question number 5. Question number 5, over here, you see nested set timeouts. So, will it be some different concept? I would say no, it will be the same concept. So, we have start and end printed first, and then we have set timeout. So, whatever we have in this set timeout, this is timeout 1, will go into the normal queue, the task queue, and then set timeout 2 after 500 millisecond will go next. And then if you print it, so it will print start, end, timeout 1, and timeout 2. So over here, start and timeout 1, timeout 2. Good. Question number 6. Over here, we see here console dot log timeout with 0 milliseconds. So we might be expecting here that this set timeout, because it is 0, it should be immediately printed. But no, we have here two concepts working. One is the normal queue, which will put this console dot log block into normal queue, meaning start and end will be printed synchronously, and then set timeout will be pulled in from the normal queue, will be put into the call stack, and then it will come to execute, which will be timeout. And also this is giving you the additional delay, right? So I is equals to 0. This is a block level scoping. So this will add additional delay to this. So it will be start, end, and timeout. So let me quickly write question number 6, which is here. Start, end, and timeout. Question number 7. We have queue microtasks. So this is a high priority VIP order will go into the microtask queue. So start, end, microtask exit. Remember, queue is queue, right? No matter what, all the things which are synchronous, like start and always will be printed first. Even if it is a micro task or a VIP order, it will not be taken into a synchronous way. It should go into the queue and then come. So, but there are two queues, like normal queue and VIP order. So, you know what I mean. So, if it is a normal queue, it will be less priority. So, priority queue will always be taken as a high priority stuff. So, but still, like start, end, and micro task executed. So, question number 7. Question number 8. Over here, we have start and then we have nested promises. Will it change any concept here? No, will remain same. Start and end start and end will be printed first, and then promise will be resolved because it will go into the high priority order queue, and then the other promise will be resolved. It will go again into the same queue. So it will be promise 1 and promise 2. Here we go. Question number 9. Now we have promise, resolve, and set timeout. Again, this is a higher order uh, priority queue, which is then now this is a lower order priority queue. So promise, resolve will be printed first, and then timeout inside promise will be printed next. So that is question number 9. You will be interesting uh, to understand this concept. So now we focus on one more, which is promise, question number 10. So what will happen over here? So question number 10 is where we are using async and await, right? So let's start. Start and end always go first. And then we have this function here. So 9, it will print async log. And this line will put it to this VIP order queue, will be pulled in from the queue, put it into the callback, call stack, and then async end will be printed. So start, end, async start, async end. So this is question number 10. So that is pretty much all from here. Thanks for watching. I see you in another video.